All right. Good afternoon, everyone. A pleasure to be here. Today, I will be presenting to you a study that we conducted on eye tracking technology for children with dyskinetic cerebral palsy. Technology is a very important part of our everyday life. We use it for educational purposes, recreational purposes, for communication, or to do presentations like the one I'm presenting today. In order to be able to do that, not only did I need a good computer interface, so my mouse and my keyboard, but I also needed something more important, the ability to be able to use it, and that's the fine manual coordination. As you see in these videos, these are individuals with dyskinetic cerebral palsy. You see abnormal postures due to sustained muscle contractions. They have a lot of involuntary movements and distorted voluntary movements due to dystonia and choreathetosis. So we can conclude that these individuals are not able to use conventional computers like we do, and therefore would benefit from assistive devices. Eye tracking technology has been widely used not only nowadays, but in the last decades for people with severe motor limitations in order to support their needs. Research suggests that after the use of eye tracking, we have an increase in functional independence, we have an increase in activity and participation levels, but also an improvement of the overall quality of life. Research in dyskinetic cerebral palsy, unfortunately, is still scarce. The latest study on DCP focused on young children, and they concluded that children as young as 3 years old are able to acquire skills to operate with the system, and the goals which were identified by the parents were met after 6-week training. However, these are still focused more on perceptions of caregivers, parents, teachers, and we wanted to have a look or increase our insights whether we can quantify the gaming performance and see how these children learn to operate the system. Therefore, we set up a 5-week eye tracking gaming intervention for children with dyskinetic cerebral palsy. Our first aim was to explore the participants' ability to acquire specific eye tracking skills by quantifying their eye tracking gaming performance. And the second aim was to report the clinician's perception on the impact of this training on quality of life domains. We included 10 participants with dyskinetic cerebral palsy, aged 6 to 13 years old, GMFCS and max levels 4 and 5, who were able to shift their eye gaze fixation and who had an ability to understand and follow instructions. The duration of our study was 15 weeks in total, and we administered 4 measuring moments: baseline, pre-intervention, post-intervention, and follow-up. Our intervention phase had a duration of 5 weeks, and during these 5 weeks, every day, children with dyskinetic CP were playing 30 minutes a day eye tracking games with the help of their clinicians. For the data collection, we selected 6 games with an increase in difficulty, who we were also able to quantify. And we used the PC iMini Tobii eye tracker, which was mounted on the laptop. So what you see in these little clips is an actual performance by one of our participants, and based on the type of gaze that was necessary to play the games, we divided them into dynamic gaze games. The children needed to shift their eye fixation as fast as possible to get as many targets as possible, or the static gaze games, where the child needed to be able to dwell or fixate for 1 second in order to perform. We generated a success rate, so in a 90-second standardized performance, we counted the targets, and that was our outcome measure. For our second aim, we included a Likert scale questionnaire with 12 statements as to where an improvement was seen after an eye tracking intervention, and this was administered only once post-intervention. So now the fun part, we have the results. For the total targets, as we see, the median increased from baseline to follow-up, and this evolution of progress was also statistically significant. As far as the static and dynamic gaze games are concerned, we see the same pattern. So from baseline to follow-up, we have an increase in success rate. That means in quality of performance. As far as the participants are concerned, this is the graph which has the data of all 10 participants, and we see that from baseline to follow-up, we have an increase in performance. This means that in a heterogeneous group, like dyskinetic CP children, who have different abilities to perform, different limitations, we see that they're all able to actually get better in eye tracking performance. So in baseline to pre-intervention, 6 participants improved. After our intervention, 9 participants improved, and then we were back to 6 participants. For the eye tracking Likert scale questionnaire, out of 120 statements and no missing data, we see that for the majority of the clinicians were neutral, neither agreed nor disagreed with our statements. However, we do have 27 statements which were pro and 0 which were against the use of eye tracking. And to translate this a bit in more comprehensive sentences, in a descending order, the major improvement was perceived in the increase of confidence and self-esteem due to achievement during the play of the eye tracking games. Children were more engaging during therapy sessions, so they were more active, and also they improved in the use of technology devices. And to conclude, for children with dyskinetic CP, eye tracking did improve over time. Children with dyskinetic CP, more importantly, are able to train and acquire specific eye tracking skills like this dynamic gazes or static gazes, which are very important in the everyday life use of a computer, for example, to select or to make choices. Self-confidence and self-esteem, which are highly important for a quality of life, are able to be improved by a use an assistive device like an eye tracking. And for everyone who is working with children with dyskinetic CP, we highly encourage introducing, trialing this device because it is a promising computer interface for this population. Thank you. That's it.
Thank you very much. Do you have any question? I have one.
No, there's one over there.
Sorry. Just yet.
It's Tim Adlam from UCL. The Tobii eye tracker is great technology, but it's quite expensive. Did you look at eye tracking with any lower cost technology that might be more affordable in a consumer product type context?
Yeah, I know that it's a very expensive technology, and that is the reason why it is important for us to be trialed in order to convince the funding body to actually support it. This is practically the cheapest eye tracking device that we were able to use. And that is the reason why it's a pilot study, and future studies we tend to include more expensive devices. It's well worth the money, I would say. I've had experience with working with children with dyskinetic CP, and they do remarkable work with it. So not only do they use it for communication, but I've seen that they also use it, for example, for mobility purposes. So it's an investment that would influence or improve not only communication, but a lot of aspects which are important for a good quality of life.
Thank you.
Yes, thank you very much.
Yes, thank you.
Next, bringing us home, we have Juliet.